Until 9 minutes and 11 seconds. Is that 9? Okay. Don't draw the graph. You don't need it. Don't draw the graph necessarily. You don't need it. And if I could delete it, I would. I'm going to go ahead and solve this as though. I'm going to go ahead and solve this as though I didn't have the graph. Because if I did have the graph, well, man, I can just steal y's out of there. But let's say we didn't. Well, let's do it this way. We'll use the graph in A, and we'll use the function in B. So, with the graph, for letter A, how am I going to find the average rate of change from x is negative 2 to x is negative 1? Rise over run, which means m equals, what do you want to choose as your y2? This one?
2.
Okay.
Yeah.
2 minus, what's the other y value?
Negative 2.
All over,
Negative 1.
make sure they pair up, minus.
Negative 2.
So then since my m is 4 over 1, then my average rate is 4. If I have a graph, I can just steal points and do y2 minus y1 over x2 minus x1. Now letter B is, what if we didn't have that graph? We could still do it. So I'm showing you, what if we only had the function? Plug the x's into the function. So what you could do is do, now we have 0 to 1. So we would find what's f of 1, what's f of 0. We would go up to our function and plug it in, plug it in. I'm doing quick plug-ins if that's okay. Plug it in, plug it in. And now I can say, oh, for my m, y2 would be the f of 1, so negative 2, minus y1. And I'm just going that direction. We could go a different direction. But I'm just going top minus bottom. So y is subtracted, and then x is subtracted. And what were my x's? 1 and 0. So then m equals negative 2. Then my average rate, technically over 1. Ugh, I'm too tall for that part of the board. Does that make sense, how we can use the function or the graph? Just depends on what they give us, Kristen.
So, what makes you use the function instead of the graph?
It was more just modeling. What if that wasn't there at all, and they just told us that? Could we do it? Yeah.
Okay, and where did you get that formula or wait,
This one?
yeah.
Up here. They gave me
okay.
yeah. So they gave me both, so I'm like, hey, let's use either one and be like, hey, if they gave me only one, could we do it?
Okay.
The answer is yes. Any other questions from last night's homework on the idea of average rate? All right, last thing. Symmetry. Did we already talk about symmetries? Yeah, that was like section 1 and 2. 1.2, I think. 1.3, something like that. And we're still just talking about symmetry, but there's a new way of talking about it. If a graph is a function, it passes the vertical line test and could only have 2 possible symmetries. If you go back and review x-axis symmetry, can that be a function? No, it fails. So it can't have x-axis at all. It can either have y-axis symmetry, and there's a new name for it now. Here's just a descriptor. Anything with y-axis symmetry we can call even. So you can connect it with that symmetry test we did before. And anything with origin symmetry we call odd. Oh, I wrote that one out. Whatever. So just 2 new words. You guys had a few homework problems, probably not tons and tons. And if you guys remember from before, we didn't use function notation to express it because we hadn't really covered function notation yet. But we did plug in negative x's. And if the negative x, when we simplified, ended up not making a difference, aka we plug in negative x, function stays the same. Remember, we would simplify, and if the function stayed the same, it's even, or it has y-axis symmetry. And I think technically our other clue was plug in negative x and plug in negative y and test. But another way of looking at it is just plug in negative x and it should be the opposite. Plug in negative x and it should be the opposite. Everything is the same, but all the signs are opposite, or the entire function is opposite or negative.
You ready to plug in negative x?
Yeah, but the other trick is plug in negative x and negative y. Function stays the same. So the idea is plug in a negative x and it makes the y negative. Or plug in negative x, negative y, and it works. There are two ways of doing it. So just two new names, okay guys? It's not new solving per se, it's just new names. So if we were to look at a few examples. Don't even worry about writing them down. Let's just look at them. Okay? Let's just steal, I think you guys had some of these for homework. Do you have your homework close, your spiral? Which ones did you have?
75.
Okay. Let's just peek at, if you want to, get your homework out. Let's peek at them. And maybe you got there, maybe you didn't. But let's peek at them all together, and then maybe I'll pick another random one for us to look at. Let's start with 71, 75, the ones from your homework. So even or odd, symmetries, negative x. Plug it in and simplify. So for 71, if you guys haven't done it yet, you can just say even or odd as your directions and then write your function. If you haven't gotten there yet. But otherwise, let's do it all together. We plug in a negative x. And when we do that, remember, inside, think of each of these as having little parentheses, right? What happens when we simplify? It's even. It's even. Even. You have negatives that are all paired. They'll become positives. Stay the same. So hence, what kind of symmetry does it have?
Y-axis.
Y-axis. And if it has y-axis symmetry, it's called even. But if you want to think about it, for the most part, if you only have x to even powers, it'll always stay the same. Way of remembering. Kristen.
Sorry, I'm just confused. Why we're doing negative x?
Page 4. The clue was test with a negative x and see if it simplifies to be the same as without negative x.
Okay.
So our clue on both of them is plug in the negative x. It's technically back from a long time ago when we were plugging in negative x's or negative y's, negative x's and negative y's. But since we have functions, we only are doing the plugging in negative x part.
So if it can't simplify without it being negative,
If it
like if that one could simplify without us switching into negative, we would do it that way. Or
No. If we're asking ourselves the question even or odd or symmetry, whichever question they ask, we put in a negative x and ask ourselves the question, what happens when we simplify?
oh, okay.
Does that make sense? Yeah. Okay. So what if we were to go to number 75? We're going to plug in negative, different variable. We got this. Just make it negative s instead of negative x. Keep it in context. Now some of you are like, I don't even know what s to the 3/2 is. Okay, hold on. If we were to take away the divided by 2, don't we know what to do? Isn't it just negative s cubed? So keep that. 4 is out here. He's just chilling. It's going to be negative s cubed. But as soon as we have a fraction, think, what kind of weird root? Wait, weird power. The 3 is the cubed. The over 2 is the square root. If it was 3 over 3, it'd be 3 and a cubed root. Oh, that becomes 1. Yep, it does. That's what's going on.
Wait, is it?
Go ahead.
Oh, I get. Because I saw on the internet and the guy wrote no symmetry. Now I see it's going to become negative s.
So yeah, if we keep simplifying,
It's 4s.
remember a negative cubed stays negative. But what happens when you square root a negative? It's not negative. It doesn't stay the same. I got issues. There's nothing going on. Does that make sense?
I did negative 4s to the third over s
You were
squared.
thinking, oh, you read the power wrong.
Yeah.
Does that make sense? So the 3, the cubed is good, but the over 2 doesn't mean divide, it means root. So, okay. And if it was a 4, it'd be a 4th root, etc. So this one, the negative can't come out, so it can't be odd. If the negative came out, we'd be good. And it can't stay the same because it doesn't cancel out. Now let's do one more. Let's do number 72. I said I might choose one extra one. So if you want to do this in your notes, it's not a bad idea. It's not a homework problem specifically, I don't think. You just said 71, 75. So number 72, and I'm going to insert a new page just so that this doesn't get too crazy. We're still trying to ask ourselves the question, even or odd. And our function is g of x equals x cubed minus 5x. Okay, you guys tell me, what do we do to test? Plug in negative x. And we have to plug it in. Don't forget your parentheses. You guys go. And give you a 30-second head start. Simplify. What happens? Stay the same. Become the opposite. Or a little bit of both, which means none. You get 10 minutes. One way I kept it, what happens when you simplify, one way I pulled out a negative. You see how it's the original, but opposite? Or you can think each of the signs are opposite. If it's opposite, opposite is odd. Opposite is odd. Does it kind of make sense a little bit? Okay. With that, I think we're to the end of section 1.5. We have about 15 minutes left, maybe a little bit less. Let's go ahead and grade our... that's not on the quiz tomorrow. Can we just forget that till later? Let's go ahead and check the evens and homework. Once again, not on the quiz tomorrow. Don't stress. We'll talk about it later. Okay. Alright, let's get to those evens. Section 1.5. Number 2. You guys have your color pen close. Number 2, zeros. Otherwise known as x-intercepts. Number 6, odd. Which you might not have quite known. But now you do. Number 2, zeros. Number 6, odd. Number 20. Let me give you a second to check it out. You're supposed to solve for the zeros. And the only reason I expected you maybe to be able to get this one, even though it was a nasty cubic, was because grouping actually worked, which doesn't always happen. Huh? Oh, it's not the same one?
No.
Lame. Alright, what was your problem? I wondered why I gave you this crazy one. Oh, I did give you an easier one. Was it f of x?
Yeah.
That's it? What do you pull at?
X.
You could pull out the x squared. You get 9x squared minus 25, which is a difference of, or could become,
0.
see it? So then I could say my zeros are, can I do plus or minus? Okay. Is 32 right? X squared minus 4x? Decreasing on negative infinity to 2. Increasing on 2 to infinity. I'll give you a couple seconds.
So in those you always want it open.
Yes. Yes. Increasing, decreasing, constant. For me, always keep it open, even if the book says closed. We good? Number 36. Does that look right? You guys did a good job on the other one. Just let me know if it looks funny. Yeah.
Are we not supposed to use the bracket notation? Are you sure this for like the inequality?
She said always open.
For 36?
No matter what.
Yeah, for 36.
No, remember increasing, decreasing, constant, I ask that you always keep them open. Yeah. It's more of just kind of a technique on specifically only increasing, decreasing, constant. Good question. Wait a minute, were you guys literally just like finding stuff in your grapher?
Yes.
Graphing calculator handbook, that was easy, right? Oh, okay. See grapher? Problems matching up?
Yeah.
52.
52, did I skip it? 52 is this. Do you need a couple more seconds? Sorry, I see people still.
Oh, right. Okay.
Now, Rachel? Symmetry question? What is that?
Those directions.
It's trying to get the intervals, I think, isn't it?
Oh, where it's higher, but it's never higher, so the answer is like none. 60 is like none or never, because it never goes higher. If you think always positive times a negative, always wah, wah, wah. Y-axis symmetry, which means even. Are we good? 60 is never, 80 is even. 60 is never, or none. 80 is even. This one, go ahead and write it down, but remember, not on tomorrow, not for tomorrow. We'll deal with another day. Easy. Yeah. If you guys want to write 2 over y is the answer for 86. 2 over y is the answer for 86. Very good. All right, as soon as you're finished reading homework, I want one volunteer from each group to come on up and get an expo marker number 1, a little baby pretend personal whiteboard number 2, and then a rag number 3. Ready, set, go. As soon as you're done grading, one volunteer from each group. Come on up. Grab one of 3, a marker, a towel,
What's that?
and a little personal whiteboard.
I think you still have the best half, right?
Whoever got it, you get to write first. But you only get to do one problem, then someone else has to do the next one, someone else has to do the next one, etc. until everyone has done one. Then we'll don't write this down. However, if you have your phone, you might want to take a picture. It'll be saved online. These are the main topics for tomorrow's quiz. What I meant was don't write this down on the little whiteboardy thing, because that's going to be what we're going to use for class. But if you want to take a picture, does anybody not have their phone? Do you want to write it down? Does someone have your number? They can send it to you. Is it like, hey,
Yes, it is.
Go ahead and write it down if you want. The main topics. Why am I telling you this? Because there was a lot in section 1.1 to 1.5. Some of it was like calculus-y things, like rectangles and semicircles and weird things.
That was fine.
This is the most important stuff. Oh, I'm missing one. Huh. What am I missing? Section 1.5.
Interval.
I'm missing one more, but it kind of comes up here. I'm not going to do range though, because that we need to get better at graphing for that. Sorry, I didn't put the main up there. That's weird.
Wait.
I'm gonna take another picture. All right, first person, markers open. They're the only ones allowed to be writing, but the rest of the group can collaborate. The point is not to be first, the point is to be right. Got it?
Sean.
Got it? The point is not to be
Sean.
first,
It's getting gnarly.
the point is to be right. Okay, what I say to you, I want you to write down. What I say to you, I want you to write down, then you can go about actually following the directions. Okay? Find me the equation of circle, the circle equation, for, okay, write this down.
Oh, wait.
Center, write it down, center is -1, 3. Radius is 5. Go.
So that'd be
You can talk to them, but they have to be the ones writing. Never take that marker from them.
minus
Double check before you put it up.
x plus y squared plus y
Someone get your notes out. Well, tomorrow you can't. Hold it up if you think you're right. I have a right answer.
Good job, Chad. That's it?
Is that a minus and -1?
Minus.
Negative 1. Mine is
I
negative
have
1.
2 right answers. 3 right answers. 4 right answers. Keep going.
This is the formula. Okay. Equals the radius squared.
Plus y minus a.
Like you get it.
If you already got a right answer, erase it and pass it on to someone new.
Alright, Luca, it's your turn. Congratulations.
All right, good. I got all right answers. So we're all tied. Okay, someone new has the marker. Number 2.
It's getting gnarly.
Number 2. Not this time. We don't have a lot of time for it. Write down the following equation. Y equals 4 plus the square root of x minus 1.
Oh.
That's why I write big.
The question is 3, 2, a solution.
It's 3 to a solution.
And you have to show me why, yes or no.
What the
x and y, right?
Oh, okay, I get it. Oh, yeah.
Yeah.
2 equals
4 just for plus the square.
No.
And then just it don't work. It don't work out.
Well, we're not rushing.
Yeah.
No.
No.
Yeah. We vibing.
Are you sure?
Pull out that. Yeah, no, because it's an irrational number. So
Good,
Because
doesn't
2
work, right?
is not 4 plus
Good.
x squared root of 2.
I don't like it.
Good.
You understand? Luca. I mean, I get it.
Yeah, I got it.
Wait, then you want to do the earlier one? Okay, I can do that too.
Okay, if the quiz is like this.
Alright, pass it on, number 3.
Here we go!
Find
Yeah.
the x-intercepts, otherwise known as the zeros. Depends on the question what it might be as. For y equals x times the square root of 2x plus 1.
Why did you put this square root in the mix? Okay.
Find the x-intercepts or zeros. Tomorrow I could also ask for y-intercepts.
So. Well, x equals 0.
Quick hint,
Quick hint.
if it helps. Think of it like
So that's what I'm saying. X equals 0. It's a 0.
So one of them's zero.
Yeah, she said yes, she said yes.
No, 0 doesn't equal that.
Hold this. And then set it down.
Okay, but how are you going to take it out the square root?
there are two answers.
You square root is 0 and this.
That's what I said, and you looked at me like I was stupid.
Yes, no. I feel like that.
Thank you. That's why I was thinking that.
One divided by
Alright, we got it. I didn't get what you're saying.
Negative
1/2. Good job.
Thanks, Lucas.
0. No problem, Kristen.
Hey, you get it?
Yeah, I do.
If you haven't finished it yet.
Oh, yeah. Oh, I got it.
Nice. Number 4. Last one.
Oh, that was a
Wait 30 seconds.
Oh, shit.
Even or odd? Or neither?
Hold on.
Y equals x cubed plus 1.
So x is negative, and then it's still stays there. No, it wouldn't, it's not.
It's done, yeah, because it would be
It's not a reciprocal. It's not a reciprocal, and it has to stay the same.
Wait. See the answer.
I called it.
Why?
Yeah.
Opposite? Same.
Nice.
That's neither. Erase it. Put it back and out of here. It has to be all opposite or all the same. Bye, guys. Erase it. Study. If you have questions, I'll be here after school. Give me back my marker. Your marker that I am taking care of.